stability kind of test here. And I like to compare it to kind of an analogy to human health. So when you go to the doctor, say you're feeling kind of cruddy, and you go to the doctor, and of course you go and see the nurse probably first. And what does the nurse do when they take you in? They do a couple things. What do they do?
Blood pressure.
Okay, blood pressure, temperature.
Height, weight.
Yeah, all the vitals, right? Okay, so let's say the nurse brings you in and your temperature is kind of high. So does the nurse recommend a treatment at that point?
Yeah, COVID test.
That's another test. So they don't really know what's wrong with you at that point, right? They just know you have an elevated temperature, probably an infection. Something is wrong, but they're not really sure what yet. So that's kind of like this infiltration test is for soil. It's just an indicator. It tells you if the soil is working well or it's maybe not working so well. It doesn't really tell you what's wrong, but it tells you something is wrong. And then we got another one over here. It's called a slate test. It measures aggregate stability. This one is a little slightly different. So then they see some symptoms and they suspect that, hey, I think I know that this is like strep throat or something. So then they do, help me here. Yeah, they do a strep test. Yeah, okay, I kind of forgot what that was. All right. Anyway, and so that's kind of what this test is here. We suspect that we know something's wrong. We're going to do this slate test and see if aggregate stability is a root problem with this soil. And so that's kind of like that's what this test does. So we'll start with this one, and I'll just put a disclaimer out there. Obviously we can't test these samples ahead of time because once you put them in, they're done. So I hope they work. So this one on your right gets tilled frequently. The one on the left has been long-term no-till. I think at least 20 years. And so do you see any differences between them? Yeah, pore space. This one on your left has some holes in it, or pore space, and some activity going on. Biological activity probably is what's creating those pores. So there's a definite visual difference between those two samples, right? So we're going to see if they act differently in water. So we'll put them in the water. And what this test does is that as you put them in the water, if you kind of watch, you'll see bubbles start to come up from the sample. And what that's doing is the water is kind of rushing in to, working its way into the sample. The airspace is being pushed out. And then as that water goes in, it's putting pressure inside that clod, and it's causing it, and it's a test to see how well that clod or that soil bed hangs together. And we'll kind of we'll let that go for a while, excuse me, and just kind of see what happens. You can see already both of them are losing pieces, right? But what do you notice between the conventional till and the no-till as far as this column here? You see a difference? It's losing it faster, but also it's a little more cloudy, isn't it? And you'll see this continue as we go on. This tube will get cloudy. This tube is losing pieces, but they're just smaller aggregates. So the aggregates are still staying together. Like that thing I was carrying around is what we call a macro aggregate. And it's made up of smaller aggregates. Each one of those aggregates will stay together almost indefinitely in water like that. And if you come up here later and look at the bottom, you'll see little like cottage cheese in the bottom, whereas this one will look like just a pile of soil probably. And you can see on the back what the management is. I'll kind of go through it quickly though. But so these are all a loam soil. 4 of these samples came from Beetle County. One of them actually came from Hyde County, but basically all the same soil though. And so we have continuous season-long grazing, fairly heavy grazing here. We've got rotational grazing. We got long-term no-till that we planted a cover crop into the tray. And these two are the same field. This one just had a cover crop planted in it, and that one's just got residue. And then we got conventional till. So what this does is we're going to rain on it. I knew we forgot something.
Rain gauge.
Yeah, rain gauge. I'm sitting here looking at it. It's been a little while since I've done one. Anyway, so we're going to rain on it 1.5 or 2 inches. And what will happen is you'll see whatever runs off, which is what we don't want to see, whatever runs off, there should be a stand somewhere.
I think it's broke.
Oh, it's broken. Okay. I just leave it there. Probably. All right. Whatever runs off here will come out this funnel in front and be collected in this jar in front. Whatever infiltrates through is what we want to see. That'll go in the jar in back. There's some holes in the pans, and it'll go in the jar in the back. I can show you. There's a pan there. I guess that's all my pans. But these pans are real quick. So this is what the pan looks like. The sample's in. It's got holes all the way through it, so the water can go through, if it can anyway. So I think we're ready to go, right?
Yep.
All right. So we're gonna get this started. So as this is going, in your mind, just try to think which ones are going to have a lot of runoff and which ones are going to have a lot of infiltration. And try to take a stab at it to see if you can guess. So this is falling apart pretty good, huh? Every once in a while I pretend like I accidentally bumped the table. And to give it a little agitation. Yeah, you can see this column here is really cloudy. If I walk around with it, it agitates it more. But you can just see that the silt and clay particles are in suspension in the water. That's what makes it cloudy. This one here, though, as we said, it still drops aggregate. But the neat thing is the water column stays pretty clear. And so the micro aggregates are all hanging together still. And they will for a long, long time. And that's creating habitat. If you think about it, the critters that live in the soil, you have predators, you have herbivores, you have omnivores. It's like a whole ecosystem underground. And they need a habitat to live in too. They need and reproducing and making the soil a better place. So we're starting to see some action going on here. Austin, you want to add anything?
I guess the first thing I always like to look at is on the soils that are bare, you start to see a lot of actual soil particles splashing on the back there. So that's actually erosion. So when it rains and we have bare soils, every time that raindrop hits the soil, it's going to move soil particles, especially in a system that doesn't have the biological glues that are keeping the soil particles aggregated to good root depth. That's very important for water infiltration. Look at the erosion there too. A lot of soil in there.
And you would think with a tight sod of Kentucky bluegrass or blue grama and buffalo grass, you wouldn't have a lot of sediment. But I've found just the opposite. You get a lot of runoff and a lot of sediment. Even though the ground is completely covered, you would think with grass and roots, but it's amazing to me how much sediment that produces. So looking here, what does that equate to? Can you put a dollar amount on that? There's some figures for every inch of water that's run off of a grassland. It's from 150 to 200 pounds per acre of production that's lost. And so whatever an AUM is worth for an acre of grazing, you can just cut it by 15 to 20% for every inch of water. So that's real dollars on grassland.
That was like 3 inches.
Yeah, we put on 3. Some of these samples were really super dry, so I let it run a little longer because they were soaking up the water pretty good. But these two didn't soak up much water at all. They ran most of it off. On this, the no-till, there's a little runoff, but I think you could probably drink it if you want. It's pretty clean. But you know, I'll drink this one here on the conventional till.
Went into the ground.
This one was so dry that it just soaked up a lot of that 3 inches in the profile. So it didn't infiltrate a ton, but it didn't run off any hardly. And this one here, a little bit of water got in the infiltration jar, but it was runoff from the sides. You see how dirty the jar is. It just accidentally got in the jar from the side runoff. So, all right, so we'll do one more little thing here and look at what it looks like underneath. And then, so this is the infiltration jar. Yeah, bring that tarp out. That's the runoff jar for the no-till. This is the runoff jar for the so this is the runoff for the conventional till. That's the runoff for the no-till. Alright, this is the infiltration for the no-till, and this is infiltration for the conventional till. Alright, so alright. Alright, so go ahead and do yours first. Do it on the right hand side of yours.
Look at all the crusting that field would have. Like this one here, it's not going to dry out and bake the soil surface. That one will. Want me to flip it over?
Look at that. Isn't that beautiful? It's just so cool looking. Alright, now we'll do this one. Did you see the dust fly up? Look at that. Still dry in the bottom. So we had 3 inches of rain and we got through maybe into an inch there. Most of the way through it's still dry. But look at this one. The cool thing about this is you can still see the aggregates in there. Even after it got totally saturated, you can still see the aggregates. So it's really, you know, very distinctive difference between those two. We can't even get water through the profile on this side, even with 3 inches of rain. And with this one, it soaked it all up.